Hey, what up? I'm back. When we last left our heroes, we've been working on our user interface library, and we now have a view model which can manage the state of the view layer. The last thing that I want to do on this, before I move on to something else, is to hook up the thread which is responsible for pumping these view models if they need to make changes to the data source. As an example right now, we have this mini-map, and we would like to be able to redraw it as units appear on the screen, things like that. So that's what we're going to fix right now. My wife that I made those. Okay. So, in the context, we should have this view model manager, so we should be able to pull it out. And so, as an example, in a UI layer we have right now. Not in there, so let's go figure out why that's missing. Alright, so this is a task container, which means it's going to end up on its own thread. Right now those threads are greenlets, but once we solve the dependency, basically you want to be able to say, I have a task called UI, it needs to run after the graphics layer is drawn, for instance, so that it appears on top. Once we have those dependencies set up, we'll be able to move them onto their own threads. They'll be truly concurrent, but for now they're greenlets like you would see in Python. View Model Manager probably didn't get exported. Manager. Start that rebuild. Go with that. But we actually want to be able to add ourselves here, so we can go back and write a method on that. So I'm going to stop that build. Craft UI. So, models. Void add model. Generate those functions. I'll start that compile since we're not going to change the header again. It'll run through, it'll build the precompiled header again, get an exception or an error, the CPP file, and then we should be able to handle that. So vector, why can't I search it? I want to do okay, dereference the iterator so we can get. What's your problem? Tell me what your problem is. Has no member get. This is an instance. We want to see that the internal shared pointer is the same. Instance SUIV model SUIV. Just gonna just err on this for now, or warn on it. You shouldn't be doing this, right? But if for some reason contextualize gets calls twice, we don't want to register the pom method more than once. So, see what happens. And then we want to do the same thing. If you find it, models. Oh, these aren't actual iterators, this is the problem. So, we can't do the C11 style. So we have an actual iterator. This is what I was doing up here wrong. So what we're gonna do is same thing. that element. Order and operation, right? Because vectors are in inline memory. So I'm gonna preemptively guard against this. Because we're gonna call this on potentially another thread. I want a critical section. Normally, like all of our event pumping and stuff is, hold on. There we go. Okay. Lock, pump the event loop, unlock. For safety's sake. Ooh. Almost deadlocked there. So, often, returning them to a function is stylistic choice, right? But, since we have a lock here, you can get yourself into some trouble where you find the thing, you return, you never unlock the lock, now the thread deadlocks because it can't reacquire the lock. So, instead, lock, make changes to the vector, unlock. We could make this atomic, but I don't want to do that because kind of want. Is this constant iterator? I don't really care. Remove model, same thing. Acquire the lock. don't need to do that. Iterate over it, find it. Don't worry about the bound. Break out of the loop. Alright. I have this fear that I didn't do this in a lot of places, because I assume that we would be using things like thread save queues, like we're using our event system, because the events for sure come out of a different thread. You may have noticed I showed it in the task manager earlier, but we're using like 70% time, even though we're not really computing a lot of stuff. But in cases where, I'm sure there are some cases in the system right now that are not thread safe, and it's going to be unfun to track those things down later. So rather than, this is pretty defensive, I think, but rather than add to the problem. For example, eventually we'll come back around and make these task containers show their dependency, so that you can do things concurrently, right? But we can run the task system as if it was on the engine tick boundary. So we can say, update the view models after you've drawn, right? And now the thread which is responsible, excuse me, so we have two threads going in a two-thread system, right? The UI view model manager says, I need to run before or after, depending on whether or not you're going to push the problem over the next frame, to update the UI data sources, right? So one of them runs, the other one blocks in this two-thread case. This one finishes, right? So we don't get too much concurrency out of it since they're dependent on each other, but since the task system will be able to say, okay, I can't complete this task right now until I can't complete the repaint task until I complete the view model task, so do some other task, networking, whatever, to chew up time on that thread, so that when you come back around to test that you complete the view model, you're able to essentially access these things without concurrency problems. But we'll do it defensively now. We can come back around and remove it later. Should be in a good spot with this. So we'll come back to well, let's look at UI View Model Manager. So we just wrote UI View Model Manager. You can update, add, and remove these things. It'll step just fine when, since this is on the stack, or not the stack, but it's a value type. They'll dereference all of their pointers to, or they'll decrement all their shared pointers once this falls off the stack, or wherever this is deallocated. So that's in a good spot. What we want to do now is SUI View Model. We should do a base class to handle, you'll have this pump method, right? Which is the thing that we're going to be calling. And what we want to do now is we want to add an intermediary class between SUI view model and our command and minimap view models, which is responsible for adding and removing itself to the worker queue. So what we're going to do here is find the contextualize method. There it lives. We're going to make it virtual. I'm going to remove all of the work from here for now. We'll make the contextualize method virtual. The base class will be responsible for registering and unregistering itself from the parent on contextualize and on destructure. Excuse me, when the destructor is called. And then in command panel view model and minimap view model, we will first thing in contextualize will be to call the parent contextualize method. So let's set that up. We need a file for grass in one of the paths. This is in the UI layer. model. UI view model base. Regenerate our CMake file. Back to these in a minute. UI view model base. Is abstract. Let's go to the, I believe it was in view layer that I have UI base component, which has an abstract aspect declare. Excuse me. Types. Okay, here we go. It's going to implement UI view model. It's going to have a abstract declare UI view model base. Virtual instance SUI data source. So we'll leave that virtual. We'll leave on event virtual. Leave pump virtual, and then we'll add to SUI view model the contextualize call, which I don't have on the stack anymore. Manager. Excuse me, I didn't have on my copy paste stack, and I deleted it from these preemptively because I thought I was going to have to change it. So let's come over here, find a contextualize method. Back to SUI view model. Cool. This is virtual on SUI view model. On UI view model base, we need a virtual destructor. Context, contextualize. We'll implement that here. Virtual destructor. And then rule of 5. If you're going to define a virtual destructor, you have to define a bunch of other stuff because it's C++ 17. So I did that on the view layer of this. Back in the wrong place. I did that on the view. Did that on the view layer of this. Just explicitly define default constructor. So we're doing one other thing, which is on SUI view model, we need to be able to access the view model manager. So we'll add a virtual method for that. Contextualize is where it will require the view model manager. This method will return it. Virtual. Okay, view model manager. SUI view model base will now implement this method, so we'll have inline this. I was trying to get away from doing this. UI view model base. Have a private pointer to one of these. if you have one, the destructor, it means that you've been in the system and you need to, you're in the queue, you need to remove yourself from the work queue. Clear with override is not an override based class member because SUI view model, I never pointed this at the correct type, but IntelliSense is confused. So this is types, context. Okay. Inline view model manager, override, return underscore VM. So instance UI view model manager, override return VMM, instance UI view model manager, instance UI view model manager, view model manager. Seem like you're lying. Error type. Why don't you know what UI view model manager is? We need to forward declare UI view model manager. Says UI view model manager. Virtual instance of UI view model manager, 0. UI view model base. Okay, it seems like it cleared itself up. Return VMM, contextualize, grab that thing in the virtual destructor. Register yourself. Add model. This. Featured instance. So register yourself as the aspect. If you're in there, then unregister yourself. Okay. So, did we miss anything? We've got the pointer to the VMM. We've got data. Yeah, data. This is the API. This is lifecycle, and then it's marked as abstract, and we will virtual void. So if you want to be pumped, then get pumped. This is what we should do here, actually. We don't need any of this because this is kind of apparent. You need to implement data source, not event, because you need to tell your child what to do. You don't need to implement pump if all you are is an event handler, so we'll override that with default do nothing. UIV model manager. So this is the API. This is lifecycle. So that should be good. I'm gonna start compiling that, see if there's any grotesque out of order issues. I think I made a header only UI base component. View model base. There's the implementation of view model manager. Now we're gonna go back to the RTS, which is command, these two, and they are going to subclass from. So they no longer implement this, they're gonna go public model base, subclass from view model base. Oh, you're going to override pump. And then contextualize stuff. This is private. This is public. Constructor into a reasonable spot. It's just poop in the bed right now. There's our deserializer. All right. So the UI view model base. You don't need to implement that. You do need to implement this. Too bad there's no finalize. Let's see if there is actually. Which one is my? Prevent override. Is there a way to prevent a method from being overridden in its subclasses? A couple ideas. Make your function private. Nope. When applied to a member function, the identifier final appears immediately after the declarator in the syntax. Declarator virtual, pure specifier, optional. Struct base, virtual void struct A. You can put final. Is final like override but prevents, yeah, so final there. Override, and then in contextualize, we're going to require that they call the parent method first. We need to come back and fix these in a minute. I think it's just having a problem because contextualize is halfway through being overridden. So I'm gonna pin the stuff in mark 1. The minimap view model, the command view model, and then view model base. It's all pinned. Grab this lifecycle method. Contextualize, put that on minimap and command panel base on. Ooh. Wish I'd called this namespace RTS UI or something. Talked about that before. Colon. On event, data source, lifecycle. To make sure that those changes are propagated onto this one. Inline virtual void contextualize. Grab this shiz like that. Use subclass with virtual object now. This is all private. There's the constructor. There's the friend class. There's its fill minimap function. I'm liking this more at the bottom. Okay. So now let's clean up their subclassing. So they no longer have to say use. They need to say parent. Minimap. I want to look up how to do this exactly right. UI view model base is the nearest to the view layer where I did it. UI div, just parent, invoke parent. UI base. Ooh, non-orthogonal naming. That's going to bother Mason later on. Okay, now contextualize. You don't need to grab your view model. No default constructor exists for UI view model base. So go back to UI view model base, public, exported, craft UI exported, UI view model base, use defaults. Up that. UI view model base colon contextualize. So call the parent. Model, contextualize. Nope, that's the fill minimap function. Contextualize. It's this. Data source on event pump. We'll call the fill minimap method. Your parent is view model now. This is going to pump way too many times, so we're going to probably do some sort of back off. You could look at a StarCraft video maybe and see how often they're pumping their minimap to get a good idea of how fast is too fast. So you don't want to like maybe it just redraws every second or like every half second. Use of undefined type UI view model manager. Forward declare SUI view model. That should do it. You include UI SUI view model manager. Include the preamble. Declare UI data source. Where did I? Uh-oh. Class. It's UI view model manager. even include order hell. Alright. Well. Stupid. I should have just used floats. The layout engines use floats. I should just be using floats. That's expensive and stupid. Oh well. Whatever, got rid of some of the errors. Okay. As UIView model. UIView model manager is not defined. But when you include UI.h as UIView model, instead. Go to common. Include the preamble. Fading fast again.
You fear that love is hard to find. Not in your heart, but in your mind. Are we playing this game?
UI View Model Manager.
Are we playing this game? Are you too afraid? Or are you giving in? Let the games begin. 'Cause I play to win.
Craft UI View Model Manager. Living the dream. Okay, so that fixes that. Sorry, pretty spent. Problem solved. So I want to test if that's actually running. So okay, great. Pump methods are running. If we make a change, Cool. Mutate them. Okay, so now we're going to watch some StarCraft to see how often they're redrawing. So...
Who understands the lead?
It's a little bit hard to tell because we're watching someone else stream, but I think we can safely gate it by 3 or 4 seconds. Okay. Well, my brain hurts, so we're gonna look at something real quick. So in about a minute, this will give us some feedback. We're at 77% CPU utilization. I mean, we are streaming processing debug mode that's asking for all of its processes. Well, alright, seems fine. I'm gonna go ahead and commit that. Improving view model system. Refactoring styling into separate component. Adding tasked. Data sources onto view models. Adding view component attribute system. Oops. Okay, and that's the other one. So that's good. We'll commit that. Oh, you jerk. Mason inline edited this last night. He's like, I don't like that you did the styling wrong here. It's gonna work. It's gonna work out just fine. Never mind. Okay. Craftengine prototype.
Into the night, city lights are dancing, slowly falling apart. The shadows causing an outbreak. I'm wishing upon a star. This time I'm feeling stronger, and I know I can do better. The shadows causing
Command data sources onto view model.
I'm turning the light, we're gonna light.
Adding step functions for RTS model. Okay, so made some really good improvements this week to the UI system. It properly supports view models now. There's some styling stuff I'd like to clean up, but we have data sources, which are those primitive renderables we talked about. We have view models, which can respond to events. They can step themselves if they need to do their own updates. We have a better attribute system so that you can more specifically talk about what information you want off the component, so that you don't need a view model for every single component. And we have stateful view models now. We have that redrawing of those icons. So it's going pretty good. I'm happy with that progress. I think I'll probably clean up just a little bit more over the weekend, but next week I would, as far as being able to take a view model, well, here, to start with, you should be able to separate views across. You can't really componentize these right now, right? You have this root view model, but if you could go to another view description as one of the children here, and then if you could walk down the view tree and attach a view model to something, you would be able to get reusable components. So if we look back just a moment at the material design guidelines, these are just the icons. Material components. Components, here we go. So like these bottom navigation bars, oval chips. What am I here to do? Well, if we had if we fix up the ability to do borders, we can do rectangular borders. So we'll be able to do that. But cards is really the important one, right? Menu bars, cards. Once we implement those, we'll basically have a C++ cross-platform UI library that implements material. So that's looking pretty good. I'm feeling good about it. I'm thinking next week we'll build a tile editor for the UI layer so that we can start to draw. So right now, it's difficult to make maps, right? But once we have a UI editor, we'll be able to build some better maps. We've got most of the RTS controls that we want. It would be nice to have maybe a top bar that told what players were in, or some resource allocation menu. But it's coming along. I'm excited about it. So, yeah. I think I'm going to stop for now. Definitely be back tomorrow. Clean up some of our streaming stuff. Maybe get some better overlays. And then I'd like to be streaming on Twitch and Facebook, so setting up a node to be a repeater, an RTMP repeater, might be what we work on this weekend. Thanks for hanging out. Good times.